Alright, so now you're looking at the Unit 5 Module 3 Trig Applications video. We're going to start putting what we've been talking about into actual application problems. Like, what would this be like in real life? We don't always have triangles. Sometimes there's real life situations. So when we're talking about real life, you might encounter your angle of elevation. It's the same angle formed by the horizontal line in an observer's line of sight to an object above the horizontal line. So if you look right here, this angle, or theta, in this case, would be your angle of elevation, okay? So then you might be looking up at an object. That would be your angle of elevation, or your angle of depression is the angle formed by a horizontal line in an observer's line of sight to an object below the horizontal line. So this would be from if you were at the sun. Well, I mean, I know that wouldn't happen, but if you were at the sun, this is your angle of depression. Depressed means you're going down, right? Think of it like that. Think of your words, angle of depression. Now, what you need to keep in mind, the only thing I'm going to add to what's on your paper is that your angle of depression, these horizontal lines of sight, or these horizontal lines are parallel. If these horizontal lines are parallel, then that means that your angle of depression and your angle of elevation are alternate interior angles. If they're alternate interior angles, then that means that they are congruent. So keep that in mind as we move through the practice. Okay. So we went over what the angle of elevation and depression is, but now let's work out some problems. So turn in your flip book to the applications practice, at the very bottom, and we're going to do one or two of each type. So looking at number 27, it says, Jack is at the zoo looking up at a monkey sitting at the top of a pole. So keyword there is looking up. If Jack is standing 24 feet from the foot of the pole and the angle of the elevation from Jack to the top of the pole is 23 degrees, find the height of the pole. So, if here is my triangle, it says there's a pole, right? So from the foot of the pole, so we could say this is my pole right here. Here's little Jack. If I could draw a person. Jack is standing 24 feet from the foot of the pole. So this length right here is 24 feet. He says from the top of the elevation from Jack to the top of the pole is 23 degrees. So this angle right here, our angle of elevation is 23 degrees. Find the height of the pole. There we go. So if we look, based off of our angle theta, we have the opposite. So this is opposite. This over here would be my hypotenuse because that's the right angle. And we have the adjacent. So when given the opposite and hypotenuse, we're going to use the tangent. So tangent of 23 degrees is equal to opposite over adjacent. To solve it, you multiply both sides by 24. When you type that into your calculator, you get that x is equal to 10.19 feet. Okay, let's look at 29. We'll do 2, angle of elevation. Caitlin's mom is standing at the bottom of a water slide waiting for Caitlin to slide down. If the top of the slide is 40 feet from the ground and the slide is 48 feet long, what's the angle of elevation from Caitlin's mom to Caitlin? Okay, so she's standing at the bottom of the water slide. So here's mom. She's standing at the bottom of a water slide that is 40 feet from the ground. So there's the top of our water slide. I wish I could draw a better water slide, but that's what ours looks like. And the slide is 48 feet long. So right here is your slide, right? Like think of that Jack and Jill slide at the fair. Maybe they still have that. I don't know. It's 48 feet long. Looks like a mustache. What's the angle of elevation? So this guy right here, from Caitlin's mom to Caitlin. So they gave me, in this case, they gave me the hypotenuse and they gave me the opposite. So if we're looking for the value of x, now we have opposite over hypotenuse. So the sine of x is equal to opposite, which is 40 over 48. So this is an inverse problem because we're trying to find the angle. So if you take the inverse of both of them, so sine to the -1 of 40 over 48 is going to be equal to my x, you get that your angle is 56.44 degrees. If you had put that into the calculator. All right, so let's look at an angle of depression. Let's look at number 31. The angle of depression from a helicopter to a landing pad is 37 degrees. So, I cannot draw a helicopter. It's like an old MASH helicopter. I probably don't know what that was. Oh, looks like an alien. Okay, so there's my helicopter. To a landing pad, so down here, we'll say, is my landing pad. Probably should make it X, that confuses you. There's my landing pad. So the angle of depression from a helicopter to the landing pad is going to be 37 degrees. So the thing is, don't get confused. Your angle of depression is a horizontal line down. So this angle right here is 37 degrees. If the helicopter is 1,250 feet from the ground, so that means if we're making a triangle right here, 1,250 feet, what is the horizontal distance from the helicopter to the landing pad? Well, if you look, my angle of depression is not inside of my triangle. But I told you that the angle of depression and your angle of elevation are alternate interior angles, making them the same measure. So if this angle of depression right here is 37 degrees, the landing pad to the helicopter angle of elevation is 37 degrees. So all those parallel lines are coming back. So we're given, based off of what we see, we have the opposite and the adjacent. Because right here's my right angle for my triangle. That would be the hypotenuse. So opposite over adjacent would be tangent. So we have the tangent of 37 degrees is equal to opposite 1250 over adjacent, which is my x. So you need to solve for x. You can either switch them, because you remember, although I had a lot of questions yesterday, so I'm going to rework it. You have to solve the equation for x. So you multiply both sides by x to get rid of your fraction. So you have x tan of 37 degrees is equal to 1250. Now you divide both sides by the tangent of 37 degrees. So those go away. Plug that into your calculator, 1,250 divided by tan of 37. You get that x is equal to 1,658.81 feet. I'm not going to do another example because I think these notes are getting kind of long, but go ahead and work out the rest of them and let me know if you have any questions.